All right, here's the key for the third homework on inverse derivatives. And we start off with the explanation of the concept of the inverse derivative using f of x and its inverse g of x, given f has a point 2, 3 with a tangent slope of 4. So when f and g are inverses, f of g of x will equal x. So f is going to have the point 2, 4. That means g is going to have the point 4, 2. So f's got 0.24, g's got the 0.42. You can kind of see that f of g of 4 would equal 4. F of g of 4 is 2. F of 2 is 4. Okay, so that's the first part, the concept of like the points flip-flopping if they're inverses. 2 goes to 4, 4 will go back to 2 if it's the inverse. That's the whole y equals x reflection. Now taking the derivative of this will give us our inverse derivative formula. Using the chain rule with the o's and the i's, f and g of x, our derivatives would be f prime of, the derivative would be g prime of x. The derivative of the right side is 1. I get f prime of g of x times g prime of x equals 1, or g prime of x equals 1 over f prime of g of x. What this tells us is, if I wanted to find, say, g prime of 4, it's the reciprocal of f prime of g of 4 is 2, f prime of 2. F prime of 2, we had that its tangent slope is 4. That means g prime of 4 is going to be 1/4. And this is the concept that if you have the point 2, 4 in f with the slope 4, g, its inverse, will have the point 4, 2 with a slope of 1/4. So if you just have like this kind of table written down, this shows me that you understand the concept. You don't need much in terms of a verbal explanation. Just slopes end up being reciprocals. Another way of thinking about this is like f's got like dy dx. The x's and y's will flip. All of a sudden, g would have dx dy at that location. So dx dy would be 4. Dy dx would be 1/4. All right, so keeping that in mind, let's find the following derivatives of g prime of 4. So we look at the points, and it's probably easiest if we list these off in terms of points of f and then points of g. So f's got 2, 4 with the slope of -1/2. G would have the point 4, 2 with the slope of -2. So g prime of 4 is going to be -2. You could have also said, okay, g prime of 4 is equal to 1 over f prime of g of 4. G of 4 is 2. F's got the point 2, 4. G is going to have the point 4, 2. So this is 1 over f prime of 2. This is like the long way of getting where we just got. This is 1 over -1/2, which is -2. 3, g prime of 3. Well, let's see. F's got the point 3, 2. The slope is 5. G's got the point 2, 3. Okay, so that's not going to give me the slope of g prime at 3. We're talking about the x-coordinate of 2 for g. So the slope would be 1/5. So I'm not going to say this is 1/5, but I would say g prime of 2 is 1/5. For g prime of 3, we're going to have to look at the point f, which has the point 4, 3, and the slope of -4. G is going to have the point 3, 4. So g prime of 3 would be -1/4. Okay, so that's inverse derivatives. Given some information, same deal. Now instead of g and f and g being inverses, I'm saying f inverse prime at 5. So first, f has the point 4, 5. I can see right here, f's got the point 4, 5. The slope of f at 4 is 0. That means f inverse will have the point 5, 4. And the slope would be 1 over 0, or undefined. So I'm going to say this is undefined. I feel like this is a lot easier than using the inverse derivative formula, though that is always our backup. I could say f inverse prime is equal to 1 over f prime of f inverse of 5. F inverse of 5 is 4, because f's got the point 4, 5. There's other ways to show that f inverse of 5 is 4. F inverse prime of 4. I'm looking kind of at the y-coordinate of f. I see f's got the point 3, 4. That means f inverse has the point 4, 3. The slope at 3 for f is 2/5. It's the tangent slope. So that means the slope for f inverse would be 5f's. Looking at the point 2, 3, with the slope 1/6, f inverse will have the point 3, 2. The slope would be 6. This seems easy, and it is, but it just ends up being something that students really forget about and struggle with come AP test time, because they just forget about it. But it is something that is very easy to do. So I'm not looking at the point 2, 3. I'm going to look at the point 1, 2. F's got the point 1, 2. G's got the point 2, 1. The slope of f at 1 is 5. Slope of g would be 1/5. Okay, so those are like table problems with this. Here now I'm giving you functions. Find the derivative of g, given that f of g of x is x. That shows me that f and g are inverses. Find the derivative of g at the point given by f. So, you know, depending on the situation, you will be given like the information you need. F of 1 is 3. Another way to show that like g of 3 is 1 is you could take g of both sides. And that shows you 1 is equal to g of 3. Or f has the point 1, 3. G's got the point 3, 1. This is not necessary to do this to understand this. If you know inverses, then you know this. If I want to find g prime of 3, I need to find f prime of 1. Right? Because if I know the slope of f at 1, 3, the slope of g would be the inverse, the reciprocal, not the inverse. So all we need to do is find f prime at 1. I get 3x squared plus 2x plus 1. F prime of 1 is 3 plus 2 plus 1, 6. That means on g, the slope would be 1/6. Okay? Or g prime of 3 is 1 over f prime of g of 3. You got to find that g of 3 is 1. So 1 over f prime of 1. F prime of 1 I found was 6. I prefer this method. Okay, I got the point 0, 1 on f. What's g prime of 1? I mean, it's giving you the information you need. It's showing you f's got the point 0, 1. G's got to have the point 1, 0. You don't know what the equation is for g, but that's okay. You have the information about f that'll lead you to the slope of g. So to find this slope, which we're trying to find, all I need is this slope, f slope at 0, 1. So let's find the derivative. 2 plus, remember e to the negative x, its derivative is negative e to the negative x. If I plug in 0, I get 2 plus negative e to the 0. So that's 2 plus negative 1, so that's 1. So this slope is 1. The reciprocal is also 1. f's got the point 2, 1. I can see 2 times 2 is 4, minus 3 is 1, 1 cubed is 1, g prime of 1. I'm giving you the information that you need. F's got the point 2, 1. If I know the slope of f at 2, 1, I'll know the slope at g, which I'll have the point 1, 2. It'll just be the reciprocal of this. So to find this, I need to find this. I got to use the chain rule for this derivative. I got an outside and an inside. So this is a quick practice with the chain rule. I got 3 stuff squared. I got 2. So f prime would be 3, 2x minus 3 squared times 2. F prime at 2 is 1 squared times 3 times 2. So that's going to be 6. So since this is 6, g prime of 1 is 1/6. Okay, I got the point 2, 4. I plugged in 2, 4 over 2 minus 1. Okay, 4. G prime of 4 is what I'm trying to find. I'm giving you the information again. F's got 2, 4. We'll try to find its slope. Once we find its slope, we'll know the slope at g's point 4, 2. It'll be the reciprocal of this slope. So just practice with our derivative rules. We'll have to use the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. I don't have to worry about simplifying this, though it would be easy to do, because I'm just asking you to find f prime of 2. If I find f prime of 2, I'll know g prime of 4. So let's just plug in 2. I get 2 minus 4 over 1. That's negative 2. Since this is negative 2, this is negative 1/2. Fun. F of 2 is negative 4. That's not right. Yes, it is. F of 2, 4. 2 minus 3, negative 1 cubed. It's 4. It's g prime of 4. Okay, cool. More practice with our derivative rules. Because if I know the slope of f at 2, negative 4, I'll know the slope of g at negative 4, 2. So let's just take the derivative. Now notice, this is not a constant, it is a function, so I need to use the product rule. I need a little bit of space for this, so let's do the derivative of the first times the second plus the derivative of the second. It's an outside and an inside, but the inside derivative is just going to be 1. So I just have to worry about the outside. The derivative of the outside would be 3, x minus 3 squared, times the derivative of the inside, which is 1, times the first x squared. Again, I don't need to simplify this. I could if I wanted to, but since I just need to find f prime of 2, I can do that. 4 times, this would be negative 1 cubed, so that's negative 4, plus 3 times, this is negative 1 squared, so it's positive 1, times 2 squared, which is 4. So I get negative 4 plus positive 12, which is 8. This is 8, which means the slope of g is 1/8, not negative 1/8. It's not perpendicular slopes, they're just reciprocals. All right, let's look at this one. E to the x squared. F's got the point 0, 1. Most of the problems you will be given the information just like this. When you see this on your tests, when you see this on quizzes, you'll be given the information. I think we have a couple problems where I don't give you the information. You'll have to kind of find it. So let's find the derivative of f at 0. This is a chain. It's got an outside and an inside. Practicing our derivative rules now with e to a power when we have a chain. Derivative is e to the power times 2x. So f prime is e to the x squared times 2x. F prime at 0 is e to the 0 times 0, which is 0. So the slope of 1, 0 would be 1 over 0, which is undefined. Write an equation of the tangent to g at x equals 3. You'll need to discover g of 3 for both cases. Okay, so this is great. We do not have information about f that'll give us the easy point on g. So we want to find g of 3. And my end goal will be that y minus y1 equals my m times x minus x1. What goes here will be my y coordinate on g. We're doing the tangent to g, so I need g of 3. And the tangent slope to g at 3 will go here. 3 is going here. Okay. Well, f is going to have the point something 3. I need to find that value. How do I find it? Well, you could set up an equation. What is the x-coordinate when the y is 3? I can add 5. I get 8 equals x cubed. X is equal to 2. So f of 2 gives us 3. G of 3 is going to be 2. So I put 2 there. Now what I need to find is g prime of 3. Well, to find g prime of 3, let's look at f. F's got 2, 3. If I know the slope of f at 2, 3, I'll know the slope of g at 3, 2. It'll be the reciprocal. F prime is 3x squared. F prime of 2 is 12. So this is 12. This is going to be 1/12. Here is my equation of my tangent line to g, the inverse to f, at 3, 2. Okay, so a little bit more involved there. This is a good one. Got y minus y1 equals m times x minus 3. I'll need g of 3. I'll need g prime of 3. Okay? So, g of 3, what is it? Well, f at some value will give us the y coordinate of 3. That'll give us the g of 3's y value. I got to set up an equation. 3 equals x cubed plus x squared plus 1. I'm not going to be able to solve this easily. This is one of those situations where you can kind of just see if x was 1, 1 plus 1 plus 1, 3. That's what they're kind of leading you to do. So f of 1 is 3. G of 3 is 1. If I know the slope to f at 1, 3, I'll know the slope to g at 3, 1. So g of 3 is 1. Let's find f prime, 3x squared plus 2x. F prime of 1 is 5. The slope to g will be 1/5. Okay. Moving over into derivatives of inverse trig functions, we just have to know them. Arctangent, 1 over 1 plus x squared. Arcsine, 1 over root 1 minus x squared. Arccosine, the same as arcsine, just negative. Okay. Tricky, but things that we will have to memorize. If you are asked to find inverse derivatives, like sine inverse of 3x, just make sure you understand it is a chain. The outside is the sine inverse, the inside is the 3x. The derivative of the sine inverse would be 1 over root 1 minus stuff squared. Derivative of 3x is 3. So I would end up with a derivative 1 over root 1 minus 3x squared times 3. I'm going to write that out a little bit nicer. I'm going to square 3x. Reminder, when you square something in parentheses, it's 3x times 3x. That gives us 9x squared, not 3 times x squared. Can't simplify this. Don't square root the 1 and square root the 9x squared. The subtraction prevents us from doing simple simplification. So don't simplify. Can't simplify, not don't simplify. tan inverse at x squared. Outside's inside. Outside is the tangent inverse. Inside is the x squared. Drew the outside, 1 over 1 plus stuff squared. Drew the inside, 2x. So f prime would be 1 over 1 plus 2x quantity squared. Sorry, 1 over 1 plus x squared quantity squared. Times 2x. Simplifying that, 2x over 1 plus x to the fourth. Don't cross off these x's. You can't. You got that plus. You have that plus. That prevents you from simplifying because of the plus. Don't cross out x's unless you can factor out an x. All right, now we're finding f prime at a couple values. F prime at root 3 over 4, f prime of 1/4. Let's see. I won't go into the process. It's O's and I's. Did it for the last one. It'd be 1 over 1 minus 2x squared times 2. I could square 2x, but I'm just going to plug in root 3 over 4 first. And I get 1 over root 1 minus 2 root 3 over 4 squared times 2. Might as well put the 2 there. This turns into 2 over root 1 minus root 3 over 2 squared. Root 3 over 2 squared would be root 3 over 2 times root 3 over 2. That'd be 3 over 4. So 2 over root 1 minus 3 over 4. 1 minus 3 over 4. Let's keep simplifying. You will be expected to do this. Is 1/4. 4/4 minus 3/4. You can square root 1/4. It becomes 1/2. You take the square root of the top, square root of the bottom. Square root of a positive stays positive. It's not a plus or minus. It's just the positive 1/2. This simplifies to be 4. And that's something that I'd expect you to be getting to. So I would not want you to leave your answer like this, just for multiple choice problems. Let's see, f prime of 1/4. The derivative, won't go into it, but using the chain rule, you get 1 plus 4x squared times 4. Outside, inside, do the chain rule process. F prime of 1/4 would be 1 over 1 plus 4 times 1/4 squared times 4. That is, I'll just keep going over here, 4 over 1 plus 1, which is 4 over 2, which is 2. I'd be expecting you to get to 2. A couple more, last 2. Root 2 over 2 arc cosine. F prime is 1 over now. I'll show you something interesting when we're done with this one. The root, sorry, this is -1 over root 1 minus x squared. F prime of root 2 over 2 is -1 over root 1 minus root 2 over 2 squared. I got -1 over root 1 minus root 2 over 2 squared. Root 2 over 2 times root 2 over 2 is 2 over 4, so that's 1/2. So this becomes -1 over root 1/2. Watch what I can do here. I got -1 over 1 over root 2. This can simplify to be negative root 2. Okay? Trying to think about how I'm going to explain the next part. We'll get there. F prime 1 over root 1 minus 4x squared times 4. Outsides and insides. Make sure you have this 4. Make sure the 4x goes there. Plug in 1/8. 4 over root 1 minus 4 times 1/8 is 1/2. 1/2 squared is 1/4. So this is 4 over root 1 minus 1/4, which is 4/4 minus 1/4, which is 3/4. Okay, simplifying that. Root 3 is just root 3. Root 4 is 2. Simplifying that, that's 4 times 2 over root 3, which is 8 over root 3. Multiply the top and bottom by root 3. Maybe to simplify, you get 8 root 3 over 3. No, that's not right. Yes, that's right. Okay. What I'm trying to show you, and this might work out. Look at the cosine function. The g of x is cosine of x. Okay. The inverse are cosine, right? G at pi over 4 is root 2 over 2, right? Okay, cool. Well, that means the inverse function g has the point pi over 4 root 2 over 2. F, which is the arc cosine function, the inverse, has the point root 2 over 2 pi over 4. Okay, cool. If I want to find, now these are flip-flopped from what you're used to, but if I want to find this slope, if I knew this slope, I could just take the reciprocal of it, just like we were doing before. Okay, watch. Take the derivative of g. G's derivative, g prime, is negative sine. Find g prime at pi over 4. Okay, so the derivative of negative sine, so the derivative negative sine x at pi over 4 would be negative root 2 over 2. So I found that this derivative is negative root 2 over 2. That means this derivative, by what I was doing for all the other ones, would be negative 2 over root 2. Okay, if I multiply the top and bottom by root 2, that's the same as negative root 2. Look at that! Negative root 2. Negative root 2. So like what we were doing before works for these. It can be done this way. But with the formula, it's actually probably easier that you will always know what the derivative of these inverse trig functions. So it's beneficial to do it using the formula rather than doing this way. Let me show you kind of the same example for this. And I hope I didn't confuse you with like flip-flopping, but like, you know, I'm starting with f and I'm trying to find its derivative. Well, f is the inverse sine function. So that means its inverse g would be sine. Okay? Now, I'm trying to find the derivative of f at 1/8. And it'd be sine of 4x. Would not be sine of 4x. Sine of 4x divided by 4. So that's tough to explain. Why is it sine of 4x divided by that? I think it's actually sine of x divided by 4, not sine of 4x divided by 4. So like, how do I undo sine x? This is not important. I hope I'm not confusing any of us, but like, to undo sine inverse of 4x, I would take the sine of it and give me 4x, and then I would divide by 4. So the inverse of sine inverse 4x would be sine of x over 4. That's tricky, but watch. F. Got the point, 1/8 something. What can I plug in here to get the y coordinate 1/8? Well, if I plug in a half, or if I get 1/2 in the numerator, divide that by 4, I get 1/8. So I know that g of like pi over 6 gives me 1/2 divided by 4, which is 1/8. So g has got the point pi over 6, comma 1/8. F has got the point 1/8, comma pi over 6. Okay, watch. If I find the derivative of g at pi over 6, take the reciprocal, I'm going to get this. Okay, g prime would be cos x over 4. If I plugged in pi over 6, I'd get root 3 over 2 over 4, which is root 3 over 8. So g's slope, root 3 over 8. F's slope, 8 over root 3. Look at that. That's the same thing that I got over here. Is this something you want to do? No, this probably confused the poop out of you. But I'm just trying to show you how what we were doing before is applicable here. It's just that, it's kind of complicated to make sure you know that the inverse of sine inverse of 4x is sine x over 4. It's not as complicated to know the inverse of cosine, cos inverse is cosine, but just showing you that. And I could have done that with tangent. I could have done that with sine inverse of 2x. But just showing you how it ends up being the same thing. We're not really doing anything different, but the formula, if you know them, will help you instead of understanding the inverse function and then kind of finding the angle to give you the y coordinate and then finding the slope and then taking the reciprocal. So just a little digression showing you it's all the same. As long as we understand, all of these problems and how to do it the original way, then we should be fine.